Hello children, in today's class we are going to learn about types of soil and properties of soil. The soil is made up of particles of rock. Based on the size of particles, soil is classified into sandy, clayey and loamy. So, what do you understand by sandy soil, clayey soil and loamy soil? I will just explain. The topsoil, which has bits of rocks and humus, is not same in different places, that is of different colors and different sized particles. The difference in color and size occurs because the soil comes from different kinds of rocks. The three main kinds of rock particles can be found in topsoil. They are clay, silt and sand. The topsoil may contain different sized particles. That particles are called as clay particles, silt and sand. The clay particles are the smallest size particles which are of less than 0.002 millimeter in diameter. The silt particles, which are larger than clay, their diameter is between 0.002 millimeter and 0.2 millimeter. The sand particles are the largest size particles which are more than 0.2 millimeter in diameter. So sandy soil contains the sand particles in larger amount compared to clay and silt. Clay soil contains more proportion of fine sized particles, that is smooth particles or clay particles in larger amount compared to sand and silt. Loamy soil has mixture of all the three particles, that is clay particles, sandy particles and silt particles in equal quantity. So depending on the size of the particles, we have three types of soil: sandy soil, clay soil and loamy soil. Clay soil is heavy, it is rich in nutrients, it retains water, it can hold water, it can absorb water. Sandy soil will become dry very easily because it cannot absorb or retain water in it. It is light, warm, contains few nutrients. Loamy soil is a mixture of clay, sand and silt. It can retain water, moderate amount of water in it. Now we will discuss about the properties of soil. First property is percolation rate of water by the soil. Second property, absorption of water by the soil. Third property, moisture in soil. Percolation rate of water in soil. Percolation of water or water percolation rate of soil refers to the rate of the movement of water through the soil as it passes through the small holes or spaces between the particles of the soil. You will see a small demonstration in the next coming video.
Percolation rate of water in soil. Water percolation rate of the soil refers to the rate of the movement of water through the soil as it passes through the small holes or spaces between the particles of the soil. Let us explain with the help of demonstration. Dig 50 by 50 centimeter deep hole in soil. Cut the bottom portion of an empty plastic bottle. Place the bottle in the hole. Fill the bottle with 100 ml of water. Note the time when all the water has percolated, leaving the bottle empty. Percolation rate equals to amount of water in milliliters by percolation time in minutes. Putting the value and simplifying them, we get percolation of soil is 10 milliliter per minute.
So you have seen in the demonstration done. Same thing you can also do. You have to measure the amount of water taken and divide that volume of water or amount of water by the percolation time. How much time the water has taken to pass through the soil is called percolation time. So thereby we can calculate the rate of percolation of soil. So what you understand here is percolation rate of sandy soil is highest and percolation rate of clayey soil is least. You can take 2-3 soils, sample of different types of soil and do this activity. Sandy soil will allow the maximum amount of water to pass through it, whereas clayey soil will not allow the water to pass through it so easily. It will absorb most of the water which we are pouring on it. So thereby what is the conclusion? Sandy soil has highest percolation rate while clayey soil has least percolation rate, and the loamy soil has moderate amount of percolation rate. The second property is water absorption or absorption of water by the soil. Opposite to percolation we can say here. When water is percolating means water is coming out through it, passing through it. Movement of water through the soil is percolation. Due to percolation of water by the soil only, in the groundwater gets recharged. Whenever there is rain, if the percolation rate is good, easily water will pass through it and the groundwater inside the ground, the level of groundwater will increase. So groundwater gets recharged due to percolation of water through the soil. Now here what is absorption or percentage of water absorbed? How to calculate? You have to take some soil. Weight of the soil should be measured. Let us imagine it is 50 grams of soil has been taken in this funnel which is having a filter paper. In the filter paper we kept some soil which is of 50 grams. Now we are pouring some water. So let us imagine we have taken 200 ml of water. When we are pouring 200 ml of water through this 50 grams of soil, we are getting here the percolated water, that is 180 ml. 200 ml is poured, 180 ml comes down. That means how much ml of water is absorbed here is 20 ml. How can you calculate? Initial volume minus final volume of water gives us the amount of water absorbed by the soil. So 20 ml of water is absorbed. So U minus V is 20 ml. U is 200, V is 180. So how much water is absorbed? 20 divided by weight of soil. Weight of soil is 50 grams. So 20 divided by 50 into 100. Since it is percentage, we have to multiply with 100, which gives us the value 40%. So that means percentage of water absorbed by this particular type of soil which is put here is 40%. So from this what you can conclude is that sandy soil has the highest percolation rate, while clayey soil has least. So clayey soil, sandy soil, you take both the samples and see the absorption capacity of water is maximum in clayey soil. So clayey soil can hold or retain more amount of water in it. So water absorption capacity of clayey soil is high, sandy soil is less. Opposite, percolation rate of sandy soil is more, clayey soil is least. Loamy soil has medium water absorption and medium only percolation rate because it has got all the particles of soil in equal proportion. That is, clayey particles are also there. It has got sand particles. It has also got silt particles. Because of that, it can percolate or it can absorb some amount of water. So you have understood about the three properties of soil. Now we will see, now two properties we have learned. We will see now third property, that is soil contains moisture. So here you can see the soil which looks to be dry. Just you take some soil sample, don't pour any water, just heat it. When you heat, we can see some water vapor is started to rise. So that water vapor, after touching to the upper surface of the boiling tube, gets condensed and converts into water. What does this activity show? That soil sample which looks to be dry is not actually dry, it contains some amount of moisture. So compared to the previous two properties, percolation rate and absorption capacity, can we say which soil will contain more moisture? Which soil will contain more moisture? The soil which is holding much amount of water, which can have the absorption capacity maximum, that is clay soil, will contain more moisture compared to sandy and loamy. So all the soil will contain some amount of moisture. So in that way, what you understood, the soil which looks to be dry is actually not dry. Because of the presence of this moisture, many of the animals like earthworm, they prefer to stay in moist climate. So you can see the earthworms live in moist soil. So moisture is present in the soil. All the three properties we have discussed, and we have discussed about the types of soil. In the next class we will learn about the crops that grow in soil and about soil erosion. Thank you, children.